Now let's talk about a few different yield measures, and specifically we'll cover the bank discount yield, holding period yield, money market yield, effective annual yield, and bond equivalent yield. Start with the bank discount yield. This is used for T-bills. So T-bills are quoted on a bank discount basis rather than on a price basis. The bank discount basis is a quoting convention that annualizes the discount as a percentage of face value based on a 360-day year. So let's say that we are talking about a T-bill with face value equal to 1000, and if this is a 90-day T-bill, 90-day or 3-month T-bill, and let's say that the current price of this T-bill is equal to 980. So what is the bank discount yield? Bank discount yield is typically denoted as RBD, and the formula is the discount divided by face value into 360 divided by T. The discount refers to the discount relative to face value. So face value is 1000, price is 980, so the discount is 1000 minus 980, which is 20, divided by face value, which is 1000, multiply by 360, which is a simplification for the number of days in a year, divided by T is 90 days. So we have our bank discount yield as 0.08, which is 8%. So this is an important formula for you to memorize. Bank discount yield is equal to discount divided by face value into 360 divided by the number of days remaining. The bank discount yield has 3 flaws. The first flaw is that the yield is based on the face value and not on its purchase price. So what this means is that if you recall the formula you just saw, it was discount divided by face value and then multiplied by 360 over number of days. So normal yield measures take the amount, discount here being 20, and divide by the purchase price. But what we are dividing by is not the purchase price of 980 in the previous example. We divided by the face value, which is the amount that will be received at the end. So this is a major flaw and identified as flaw number 1. So as you know, returns from investments should be evaluated relative to the amount that is invested. So in our last example, it should have been 980, but instead we evaluate the discount of 20 relative to 1000. So this is an issue. The second is that the yield is annualized based on a 360-day year. So we use 360 rather than 365. So this is a second issue. And finally, the yield annualizes with simple interest, which ignores the opportunity to earn interest on interest, i.e. it ignores compound interest. Note that the discount divided by face value is simply multiplied by 360 divided by T. In our last example, T was 90. So essentially we took the yield, which was 20 divided by 1000, and simply multiplied it by 4. So this is using simple interest and not compound interest. You might wonder why this convention is used given all the flaws, and there is no good answer to this other than the fact that this is what has been happening for the last many years. So it's basically convention. And if you pick up any major financial newspaper such as the Wall Street Journal, when you see quotes for T-bills, it will be on a bank discount basis. So BDY, and you need to know the formula. So again, the formula is discount over face value into 360 divided by time to maturity. Holding period return should be familiar by now. If you take the example of a simple stock, the holding period return, let's say you buy a stock for 50 and it becomes $60 after a year, plus you get a dividend of $2. What's the holding period return? The holding period return is simply P1 minus P0, which is 60 minus 50 plus the dividend of 2 divided by the initial price, which was 50. So this will give you your holding period return. In the simple example that I came up with, the holding period return is 24%. Now let's say that this holding period return is for a 100-day period. What is the effective annual yield? So to get the effective annual yield, you use this formula. Effective annual yield is 1 plus holding period yield raised to the power of 365 over t minus 1. So let's plug in the numbers. Holding period yield in our example was 24%. So that becomes 1 plus 0.24 raised to the power of 365 divided by 100 minus 1. So when we do this calculation, it will tell us what the effective annual yield is for this investment. The money market yield, called RMM, is the annualized holding period yield on a 360-day year basis, and it does not account for the effect of compounding. So the formula is this: the money market yield is the holding period yield into 360 divided by T. So like the bank discount yield, this deals with a 360-day year. Like the bank discount yield, it's using simple interest, so we are simply multiplying by 360 over T. But unlike the bank discount yield, we use the holding period yield. So holding period yield is based on your profit divided by your initial investment. So in that regard, the money market yield is better than the bank discount yield. But the other two flaws that we talked about when we were discussing bank discount yield, 360 days rather than 365, and simple interest rather than compound interest, those still remain with the money market yield. Effective annual yield again. So if we continue with our example, we have actually, for the example that we took, let's just go back and make sure we know the holding period yield, and we can then calculate the effective annual yield. So if you recall, we had a T-bill that was priced at 980, and from 980, so holding period yield first, face value 1000, and this was a 90-day T-bill. So what's our holding period yield? Our holding period yield can be thought of as 20 divided by 980, which is equal to 0.0204, which is 2.04%. Another way of doing this is to simply say 1000 divided by 980 minus 1, which will also give you 0.0204. So your holding period yield is 0.0204. How do you find the effective annual yield? The effective annual yield is equal to 1 plus 0.0204 raised to the power of 365 divided by the number of days, which is 90 for a 90-day T-bill, and then minus 1. So this gives you an effective annual yield of 8.53%. What was the money market yield? So we just saw that on the previous slide, but to do the calculation for the same example, the money market yield will be 0.0204, which was your holding period yield, times 360 over 90, which is 8.16%. Notice that the effective annual yield is more than the money market yield because of two reasons. One is money market yield only uses 360 days rather than 365 days. And the second reason, and the more important reason, is money market yield is using simple interest, while the effective annual yield is using the exponent, which means that here we are taking into account the impact of compounding. Okay, here is a yield that a lot of students have trouble with. You will understand the basics right now and learn this much better when we do fixed income securities. Bond equivalent yield is 2 times the effective semi-annual yield. The reason for using bond equivalent yield is most bonds pay coupons semi-annually. That means every 6 months. And as I said, we'll study that in more detail when we do fixed income securities. So if a bond is paying a semi-annual coupon of 4%, that means on a $100 bond, you get $4 after 6 months and $4 again after 6 months. The definition of bond equivalent yield is it is simply 2 times the semi-annual or the 6-month yield. So if you're getting $4 on a $100 investment, your 6-month yield or semi-annual yield is 4%. The bond equivalent yield is simply 2 times the semi-annual yield. So 2 times 4% is 8%. This is your bond annual yield. Note that the bond annual yield is going to be slightly lower than the effective annual yield. How do we get the effective annual yield? Given that your 6-month yield is 4%, you can find your effective annual yield by doing 1.04, that's the 4%, squared, because we have 2 periods in the year now, 2 6-month periods in the year, and then minus 1. This will give you 0.0816, which is equal to 8.16%, which is the number that was given here regardless. So this is the distinction between bond equivalent yield versus bond equivalent yield versus effective annual yield. The simple thing to remember is bond equivalent yield, simply get the 6-month yield and multiply it by 2. That gives you the bond equivalent yield. Let's do a couple of examples and then we'll wrap up this reading. Say you purchase a T-bill that matures in 150 days for a price of 98,000. The broker who sold you the bond gave you the money market yield as being this. Compute the holding period yield and the effective annual yield. The way you can do this is, let's just go back and look at the formula for the money market yield. So money market yield, if you recall, is holding period yield times 360 over T. So the holding period yield is given, actually the money market yield is given as 0.04898 is equal to holding period yield into 360 divided by T, which is 150 from here. So from this you can calculate holding period yield. So holding period yield is equal to 2.041 So that's your holding period yield. And then to calculate your effective annual yield, go back to the effective annual yield formula. This is going to be 1 plus the holding period yield, which is 0.02041, raised to the power of 365 divided by the number of days, 150, and then that whole thing minus 1 to get the yield. So when you do this, you will get effective annual yield of 5.039%. And again, as a check, note that the effective annual yield is a little more than the money market yield. One final example and then we'll be done. If you have a 2-month loan which has a holding period yield of 2%, what is the yield on a bond equivalent basis? So 2-month loan, holding period yield 2%. So you need to find the yield for a 6-month period first and then double it. So if for 2 months you have 2%, then for 6 months the yield will be 1.02. So that's coming from the 2%. And then you raise this to the power of 3. Why? Because in a 6-month period you have 3 2-month periods. For each 2-month period you have a return of 2%. So over the 6-month period the effective yield will be 1.02 cube minus 1, which is equal to 6.12%. And since that's the 6-month yield, the bond equivalent yield will simply be equal to 6.12 times 2, which is equal to 12.24%. So that explains the bond equivalent yield. Now, obviously, to understand this material, you need to go back to your curriculum and your study notes and practice as many questions as possible.